Hello, let us look at wiring electrical panels or electrical connections. For this field of electrical connections, you know by following standards and norms that the most common drawing or wire diagrams are the one line diagram. When you have a wire, a single line diagram, your wires are represented by a single line, but they could be multiple lines in that conduit. So, for instance, if you have a three-phase power represented by a single line, in that line you're carrying three phases, phase one, phase two, phase three, obviously, plus ground, but your drawing will only have one line. And that is a very common representation of wiring diagrams because they're standardized by norms. Now, if you're interested in doing electrical diagrams, there's electrical AutoCAD with toolboxes and tools and commands strictly designed for electrical diagrams. So you have PLCs, panels, breakers, connections, etc. So for instance, in this case, we have fuses. You would go and insert a component from your electrical diagram, and you can simply insert the fuse. So I'm not going to insert anything because I don't want to add um, libraries and I don't want to add layers to my diagram. So right now, I'm going to assume that I have a regular AutoCAD like most of you, and we're going to create this diagram with no AutoCAD electrical toolbox. So let's start by fuses. We can go ahead and go to property layer, and we are going to create a new layer called fuses, and it can be white, that's not a problem. Then we go to arc, and we're going to create a fuse that is, let's see what snaps I have. Yeah, that's okay. We're going to create a fuse that is, I don't think we need to worry about any particular distance here. We're going to just make it random distance. So it's not going to be to scale. Okay, so that's one part of the fuse. And if you do a mirror from this point and then you rotate, yep, and then you move the arc, then this point is going to be placed right here, then that is going to be a fuse. Obviously, you can exaggerate the radius if you need to. If that's what you want to do, a fuse with a larger radius, simply what you need to do is the same concept. A mirror from this point and rotation. Okay, so again, you're going to be later on using a notation to tell people that this is a fuse, so you don't have to worry about the distance or the radius. Okay, all right. So now we have our fuses. Okay, let's get rid of this one. We actually have three fuses. So what we're gonna do is move. No, we're gonna copy instead of move. We're gonna copy both parts. And we're gonna do 1, 2, and 3. Okay, then everything else is very simple. We're got, well, except for one thing that we don't know how to do just yet. Let's do this on the same layer. We're gonna do the fuse connections. So this part right here is copy. We're gonna take the center, Take it to the center point, the center point, and the center point. And what we're gonna do is we're gonna fill the inner area with color. So for that, there's a command that we haven't used called hatch, and we're gonna say solid, this one, this one, that one, this one, this one, this one, enter. And obviously you can change the color for black or orange or whatever you want. Okay, next one is rectangular, so that should be pretty easy. Let's create a line so that we more or less know where our center point should be. Line, and remember that all of this could be different layers, but I'm using the same layer because I'm going to use the same thickness. So copy from here to the center point to the center point. Okay, so we're gonna do, we have two options, either start there or do a rectangular and then trim it. Let's try that. So I'm gonna extend my line a little bit. So I'm gonna extend it and you'll see why. So I'm gonna do a rectangle. And it's gonna be 3 by 3. Okay, and then I'm gonna move that part to have the center at the center so that I can copy the center and place it on every conductor line. All right, then I simply do trim. So select my object to trim. All right. Okay, so now we have that section right here. One thing that we can do is use that rectangle for choosing our conductor lines for the bottom section. So let's do trim again. And in that case, we simply have to trim that, this, and that. All right, okay. So let's do our line from this point to that point. Very simple. We're creating the line up here. Copy. Center to center. Okay, we don't know the distance, but in electrical diagrams, it's very important to know the distance because of the voltage drop and the current limitations of the wire. Okay, so let's do that and this. Enter. For triangle, we're gonna do a line. And we're gonna do this, and we're gonna remove the ortho condition so that we can do that. That works fine. Then we're gonna do a mirror, and we're going to go to ortho again so that we can close it. Perfect. So now if we create a junction here, we have a single point. Okay, so what I did is I typed join and I selected the lines. That is because if I create a hatch, then I can select this line. Oh, it's telling me that I need a closed boundary. And I thought I had a closed boundary. There you go. I do have a closed boundary. That's why we need to join the portions. Okay, good. All right, so the last part is creating the array of systems. So the modules, the solar cells, and for that we're going to simply use rectangular, and we're gonna do, actually, let's create a line. And then what we need to do is have a rectangle here, and then we're gonna move that, selecting the center, to this point. Okay, so now for this to happen, you have to go to your snaps and have endpoint and quadrant and node selected. Go ahead and trim. Perfect. Okay, so now we can go and copy this and select the line along the same ortho line. So now they're all aligned. And what we can do is that we can copy this everywhere. And I'm still on the same layer, but I could use different layers if I wanted to change the thickness. Okay, so let's go ahead and do trim. And we're going to trim that line, this line, that line with this line. And we have the internal portion of it. Okay, so now let's go ahead and do another layer. And let's call this enclosure. Select that. Let's go to property layers. And what we need to do next is make sure that the line is not continuous. We can put a larger thickness. For enclosures, we only have that. I don't know why. So we go to dash. Let's go to ISO. So we just need to load the line if we don't have any more. You should have different ones in case. But in case you don't see anymore, you just go to line type, double click, and load the different lines that you want. All right, so now we just need to use the annotations to finish. Well, actually, no, we have more things to do. So let's go ahead and do these. Get rid of that line, and this line was only a reference to have in our distances. We won't need that. Go back to our zero line, check that layer, and let's create rectangles throughout. So we're gonna have, we can do an array, or we can just simply create, the rectangles to our liking. So put your ortho there and there. So by copying, I can pretty much have it aligned. Okay, in that case, we just simply add our annotations, which we go to annotate and choose our multi-annotation tool and type our names. So this is our fuse. Okay, we're going to have to either scale it or change the properties. Well, let's change the properties. So on here, We go to modify and let's put 0.3. Okay. Yeah, you can fix it to whatever size you, you think is convenient. Maybe 0.5, it will be good for me, depending on the scale of your drawing, since we don't have any particular scale. Okay, fuses. Actually, I think it could be a little larger. Okay. Then we have DC to DC, PVC, etc. So go ahead and finish all the annotations, and at the end, you simply export your drawing as a layout or as a model. You can just basically place it on your layout and you can save it as your PDF.